Hi everybody, Mr. Ruger again. What we're going to be looking at today is we're going to be looking at your homework for piecewise functions, the worksheet that we did in class. We're going to be going over some things, hopefully being able to see some secondhand so we may be able to pick up as we go on it this time around. So let's get this thing started. So hopefully you guys look at that and you say, oh, hey, yeah, I remember that. Man! Golly, I had that worksheet, not quite sure where I did with it. Maybe my dog ate it, I don't know. But we're asking first to evaluate. Evaluate, what that simply means is I'm going to take this function, is actually saying f of x. So I'm taking this x value of 7 and putting it into one of these. Which one? Well, 7, you've got to ask yourself, here are your two restrictions. Is 7 greater than 4? Is 7 less than or equal to 4? Clearly, 7 is greater than 4. So we put it into this equation. So we end up with 3 times 7 minus 5. 3 times 7 being 21, minus 5 obviously being 16. So our answer here for this guy is 16. Okay? And that's really all we have to do. You're just looking for a y value. Okay? Next one, when f of 4, now we ask ourselves once again, is 4 greater than 4? No, they're the same value. So we're looking at less than or equal to, so we put it in here. So we end up with 4 squared. 4 squared we know by definition is 4 times 4. 4 times 4 being 16. Okay? And that's really it. Moving on to the next one, negative 3. Negative 3 is less than 4, so we plug in our negative 3 into our equation. The reason why I did this over here, you have to be careful here. It is negative 3 times negative 3. And Stephen Cummings must go to the main office if he's in the building. Yeah. But if you just did this in your calculator, you're going to end up with negative 9, and that's not what we're looking for. Negative 3 times negative 3 is negative times negative is a positive. This is going to give you a positive 9.
Use your parentheses, guys.
Yeah, make sure you use these guys because it's important. Once again, we're evaluating for the following value. So now instead of 2 choices up here, we now have 3. But it's the same process. F of 10, so we say, okay, 10 is clearly bigger than 1. It's clearly bigger than 3, so it's got to be greater than or equal to 3. So we say 6 minus 2 times 10, 6 minus 20, 6 minus 20, negative 14. Okay? I wish it was harder than that. If you're waiting for a curveball, I'm sorry, we're going to strike you out on a fastball down the middle. So, next one, f of 2. F of 2. Now, 2 is between 1 and 3. So, guess what? It's just going to be 3. So, this is just 3. We don't have to plug it into anything. This is a horizontal line. You need to know, horizontal line, by definition, it says for all x's, y equals 3. So, no matter what x is between 1 and 3, y is going to be 3. Nothing really to do there. You need to make sure you understand horizontal line. Last one, f of 0. 0 is less than 1, so we've got to plug it into this equation. Okay? And then we have to obviously do our order of operations. Okay? And I know that this has a P on it. Guys, those that are in my class know that this just obviously shouldn't be a P, it should be a G because it stands for all grouping symbols, because absolute value is a grouping symbol, so we have to do what's inside there first. 0 plus 1 is 1, the absolute value of 1, and the absolute value of 1 we know to be 1, so we end up with negative 2 times 1, which gives us an answer of negative 2. And that's your answer, okay? And that's how we did the first 6 evaluating, okay? Going in here to number 7. Now, when we get to number 7, what we need to know is that we need to be able to say, okay, graph both equations. So this first one, f of x, is negative 2, so we're going down to negative 2. And the next one's going to be at a positive 3, or up 1, 2, 3. Both of these are horizontal lines. So I'm going to go ahead and I'm going to stick my little straight edge that I created here, and I'm going to make horizontal lines. Okay? This is nothing more than a sheet of paper that I folded a few times. Once again, you're not looking for a ruler, you're not looking to measure anything. You just need a straight edge, and you can do that with just taking a sheet of paper and folding it a bunch of times. Okay? Now, something happens here at 0. So, step 2, I need to make sure that I'm going to erase here at 0 because something's happening there. Okay? The top function, x is less than 0. Less than, first of all, being an open circle because it does not include. Less than meaning left. So that means everything to the right I'm going to go ahead and I'm going to erase. So the first part of my piecewise function goes like that. Second one is greater than or equal to. That's going to be a filled in circle. Greater than or equal to meaning right, so we make our arrow there, and I erase everything to the left. Okay, so my piecewise function looks like this. Now here's the fun part. Like we talked about before, this right here is a discontinuity. Okay, because it jumps, because there's a space there. So it's discontinuous at 0. So it is discontinuous at 0. Okay, moving on to the next one. Now this one, two linear functions. Matter of fact, they have opposite slopes, but we're going to graph them the same way we normally would. So from the vertex, or from the origin, we go up 2, 1, 2, and then we go down 1, right 1. We go ahead and take our little straight edge here, and we connect the dots. Okay, next one is down 1, 2, and it's going to be up 1, right 1. And then we go ahead and, once again, we simply connect the dots. Okay, so we now have two graphs. And how do we go from there? We say, okay, well, something's happening at 2. Something's happening at 2. So I'm going to go ahead and erase right there. And we say, okay, well, for the top one, negative x is plus 2. It's going to be when it's less than 2. So I say that's an open circle. Less than being left, so I go ahead and erase to the right. And if you can start to catch the pattern, then that means this guy is going to be closed circle here at 2, and he goes to the right, so I erase here to the left. Okay? Now, so here's my function. Looks an awful lot like an absolute value function, because technically it could be perceived that way. Absolute value function could also, this one could also be written as y equals the absolute value of x minus 2. As you know, we could definitely get into that later, but this is actually continuous. It's continuous because the connection point, or the place here, they both have the same y value. Remember those in my class? We're looking at the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right, and in both cases they equal they're equaling 0. So since they both equal 0 from the left and right, this is a continuous function. Okay, let's move on to the next one. Same idea for this. We're going to go from here. We're going to go up 1, 2, and we're going to go down 1, 2, 3 to the right 1. And I'm going to take my ruler here, and I'm going to connect the dots. Okay, and then the next one I'm going to go down 4, 1, 2, 3, 4, and I'm going to go up 1 to the right 2, and once again I'm going to connect the dots. Okay, now something's happening at 2, so something's going to happen right here. Okay, at 2. This first one is less than or equal to is going to be this, so at 2 it's going to be less than or equal to. So we go less than or equal to is to the left, so we get rid of the right. And we know from what we've learned that because this has to be a function, it must satisfy the vertical line test, that I'm going to technically be erasing everything to the left here. And bada bing, there's my new function. It is, you know, both open and closed at the same point, so once again we're talking about a continuous function. Next one. We've got three functions. We have f of x is equal to 4, 1, 2, 3, 4. We have a horizontal, which is going to be a horizontal line here. Horizontal line. Okay. We have y equals x squared. So x squared is going to be when it's 1, it's 1. Negative 1, 1. 2, it's going to be 1, 2, 3, 4. Negative 2, it's going to be 4. So my graph's going to go like so. Okay, and then we have 4 again, which I might be assuming is not, might be a typo. I don't know, we'll find out later. But it's that same line again. So when x is less than or equal to negative 2, when it's less than or equal to negative 2, which is this point right here, it's going to be my horizontal line. So my horizontal line is going to go right here, and it's going to stop right there. Now it's going to not be anywhere else as it goes from -2 to 2. From -2 to 2, it's going to be this guy, so it's going to be an open circle here, and an open circle here. Okay? And then I go ahead and erase up through here, and then it's going to be greater than 2 here. And we say, oh, look, it wasn't a typo. And, you know, it kind of looks like a dog. I don't know why, but that's what I see. Ruff, ruff. But it is a continuous function, because once again, the limit as x approaches -2 in both of these equations gives you this from the left and from the right, is going to be the same as they would be here, and the same here. So they're both going to be approaching 4. Okay? And pretty much we're going to go and we're going to do the next one. Okay, this one, same idea. We're having plus 12. Now here's the interesting thing about plus 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that doesn't work. So what we need to do is we'll come out here and we'll say something about units equal 2. Okay, or better answer for that might be 1 space equals 2 units. Okay, so now instead of going all the way to 10, we're actually going all the way to 20. So we can go 2, 4, 6, 8, 10, 12. Okay? And now when we go down 1, we're actually going down 2. So we go down 1.5, and then to the right 1.5. There's 1. And then we need to also go up 1.5 to the right 1.5, and there's that one. And that gives me 2 of the 3 lines. Here's 1. Here's the other. Helps if I have the pencil long enough. There we go. And then the last one is the absolute value of x, which is just going to be here. When it's 1, it's 1. When it's -1, it's 1. When it's 2, it's 2. When it's -2, it's 2. And we go ahead and we make our straight lines right here. Okay? Kind of looks like the sign of, you know, the Freemasons. It looks kind of like a sextant, but, you know, that's a conversation for another time. When x is less than or equal to -3, so we're going to go out here to -3. 1, 2, 3. We come out here to -3. Something's going on at -3. It's going to be this function right here at -3. So -3, 1, 2, 3, we're going to say is a closed circle, and since it's less than, we're going to go ahead and erase everything to the right or greater than. Okay. From -3 to 3, from -1, 2, 3, 1, 2, 3, from -3 to 3, it's going to be an open circle for this absolute value, so it's an open circle here. So I go ahead and erase all this. Okay, and then I'm going to do to 3, 1, 2, 3, 1, 2, 3. It's going to be an open circle here as well. Open circle here as well. And then down here is going to be my closed circle, and I go ahead and erase everything that's in here and everything that's up here. So here is my piecewise function. Once again, 1 space being 2 units, and as we can tell, it's got some space in between, so we are talking about it being discontinuous. Okay? Discontinuous. Last one. The last one we're talking about, we've got a quadratic function. Basic quadratic function. The only difference is that instead of starting at 0, we're starting at 1, 2, 3, 4. When we go up 1, right 1, up 1, left 1, we're going to go up, or when we go to the left 2, we're going to go up 1, 2, 3, 4, and then left 2 will go up 4. So here's my function. Okay? And then last one starts at -5, so 1, 2, 3, 4, 5, and the slope is 2/3, so I go up 1, 2, to the right, 1, 2, 3. So we go ahead and we connect those dots. Okay? And then we say when x is less than 3, so when x is less than 3, we come out here to 1, 2, 1, 2, 3. When x is less than 3, this value right here is going to be an open circle, so we go ahead and erase this, we say an open circle here. And then it's going to be all of this here when it's less than 3. When it's greater than or equal to 3, it's greater than or equal to 3, which is right here, it's going to be this. So then I go ahead and erase all of this function here. So here's what my function looks like. Okay? Once again, we've got a space between, so we're talking about discontinuous. And this will help us out for the last 2 questions, because the first one says which of the piecewise functions are continuous. So in other words, which ones have no spaces. We're looking for ones that have no spaces. Okay? So having no spaces, we've got 9. If we go back to the front side, we also have number 8. So 8 and 9. So numbers 8 and 9 are continuous. And also, I'm sorry, number 10. Almost forgot about our doggy here. And which ones are discontinuous? All the other ones. So 8 and 9 are, so that means that 7, 11, and 12. Okay? And 7, 11, kind of funny story that, you know, the home of the Slurpee, which, you know, we all like Slurpees. At least you should, because they're amazing. But makes mouths happy. Thank you guys so much for listening. Hope you had a wonderful time. And good luck, and we'll talk to you soon. Bye-bye. Make sure you stop into tutorial and ask your teachers lots of questions.